rectangle about its diagonal.
Yes, sir.
Yes, sir.
Okay. So then I should have given you homework from the booklet as well.
You have given
Yes,
us
you
a
probably
very
given
good
us
answer.
1 to 20.
Okay.
सर थोड़े सा हमने हेडेक दे दिया था
They were very long.
No, there is a tricky way of doing those. I'll let you know.
So we bata
We have a doubt lecture also, right?
Yes, sir. Sunday.
Yes, sir.
And yes.
Triangle fine. Today's class by default becomes the most important class of rotational dynamics. And my cartoons have not yet joined the class. Slowly नींद से उठ रहे लोग. क्या बोलेंगे?
सर मुझे ऑफलाइन का डर लग रहा है सर, कुछ 6 o'clock को उठना पड़ेगा हर दिन.
Obvious.
Sir, what time are the offline classes in the morning?
7:30.
सर आप समझा सकते स्क्वायर प्लेनर प्लेट पे ये मतलब wherever we take an axis of rotation उधर ma square by 12 क्यों है?
X-axis, y-axis. So x-axis, y-axis can be this way also. My only condition in perpendicular axis theorem is ij should be passing through the intersection perpendicular to the plane. You turn x and y any way, it will turn out to be the same.
Okay, sir.
Conditions x and y should be perpendicular.
Sir, and it should pass through the center of mass,
It
right?
should be perpendicular to y-axis. That's obvious.
Sir, should those x and y axes pass through the center of mass also?
Naturally.
Okay, sir.
The most important class, people are yet sleeping. Jago mere Bharatwasi, jago mere Bharatwasi, samay nahi hai sone ka.
सर अभी आ जाएगा, but sir I'm guessing it will peak at 95 और फिर उसके बाद वापस निकलेंगे लोग.
अरे भाई टॉर्क इक्वेशन कैसा लेना समझाना है, इसी के ऊपर पूरा रोटेशन नेक्स्ट 10 to 11 लेक्चर्स आर बेस्ड ऑन दिस.
सब रिकॉर्डिंग देख के वो करेंगे.
रिकॉर्डिंग से नहीं होगा. Now listen. Before we start moment of inertia, we learned something called torque equal to I into alpha. I was moment of inertia, so we deviated from the regular track of rotational dynamics, derived all the moment of inertias. Now we know all the moment of inertias, right?
Yes, sir.
Yes.
Yes, sir.
Did we summarize them?
Yes, sir.
Yes,
Yes,
sir.
yes, yes, sir.
Now how to take the torque equation? ध्यान से सुनिए. For the next 10 lectures, probably there will be only 3 things that we will do. One is take translational dynamic equation. What is translational dynamic equation? Vector sum of all the forces is mass into acceleration.
Yes, sir.
Acceleration will be the acceleration of center of mass of the body.
Yes, sir.
Yes, sir.
Yes, sir.
Second equation is the rotational dynamic equation. What is the rotational dynamic equation? Torque equal to I alpha. Third equation will be constraint relations. That's all. अरे constraints हमने न्यूटन्स लॉस में सीख लिया यार, अब क्या समझाओगे? 10 लेक्चर लगेगा.
Sir, we have learned better than 2 questions.
Right.
Yeah.
So these 3 things, translational dynamic equation, rotational dynamic equation, constraints, apply करते करते 10 लेक्चर हो जाए. Now the most important among the two, you people will confidently apply translational dynamic equation. After today's class, you will know how to apply torque equation. Constraints you will keep limbing. Slowly after 3 to 4 lectures, you will get a grip on it. First of all, actually I should first dictate the rules. then take this example. But I do this in the reverse every year so that you will remember this all your life. The reason is like this. You will understand this by the time I complete this. If you two strings hanging this way and there is a thin rod kept here, and this string snaps. You burnt the string. M is the mass of the rod, L is the length of the rod. M is the mass of rod, L is the length of the rod. This is Mg, this is T. You cut this string, you burnt it, you didn't give any impulse. Right? Question asked is find the tension in the string at that instant. Find tension in the string at this instance. Which instance?
Just after.
String is
At the
When this string is cut. Now somebody asked me long back, string is cut, tension in it is zero. No, yaar. Why will I ask you tension in that string? I didn't ask you tension in this string. I'm asking tension in this string. When the right string snaps. Right? So, what was the key factor we have decided that we will use for the next 10 lectures? Translational dynamic equation, rotational dynamic equation, constraint. Right?
Yes,
Yes.
sir.
Firstly, translational dynamic equation is mg minus t is m into e. Two very important points. Why didn't you take t minus mg is equal to m into a? I can take. Have no problem. That means I am assuming acceleration of center of mass is in the upward direction. Is it really in the upward direction? I don't know. Neither do I care. But in the start of the problem, I assume a certain direction for center of mass acceleration. Till the end, I will follow the same convention. I will not change in bit. If I get a negative, that means the direction I have taken is wrong. Fair enough.
Yes,
Yes,
sir.
sir.
Yes, sir.
So if somebody wants to take t minus mg is m into a, that means you are assuming acceleration of center of mass is in the upward direction. Nothing wrong with it. The equations and physics will take care of the problem. But stick to that convention till the end. You will get a negative. In the last step, reverse the direction of the acceleration. I have no problem with that. And when I write translational dynamic equation, vector summation of all the forces is mass into acceleration. Acceleration is the acceleration of
Center of mass.
Center of mass.
center of mass of the body. Now this is P, this is Q. Talk about point P. This is the key catch whole of the game about. Right? I have yet not taught to you what are all the points about which you can take the torque. I am continuously telling you, take the torque about that point, you are taking the torque. Now you will learn what are all the points about which you are eligible to take the torque. Points about which you are not eligible to take the torque. Preferred points, non-preferred points. All conditions will come in today's class. So keep your eyes, heart, and mind open. Right? Now, talk about point P. Tension is passing through that particular point.
Yes, sir.
Yes, sir.
Torque due to tension is 0.
0.
Yes, sir.
Mg into L by 2 is equal to I into alpha. Mg into L by 2 is I into alpha. You took the torque about one extreme end of the rod. Moment of inertia will be ml squared by 3. M gets cancelled, L gets cancelled, alpha is 3g by 2l. This is my second equation. Alpha is about point P. statement is wrong. Rigid body theorem tells us angular displacement, angular velocity and acceleration about any point of the body is the same.
Yes.
Yes, sir.
Even if I would have taken torque about center of mass, alpha will be the same. So don't let that drag you down. You keep wondering alpha is body is rotating about which particular point. You say आपको कुछ लेना देना है. Is body rotating about point P? I don't know. Is it rotating about center of mass? I don't know. But about whichever point you take the torque, alpha will be the same, rigid body theory. Now comes the complicated thing called constraint relations. If a body is going in a circular track, this will be R alpha, this will be R alpha, this will be R alpha, this will be R alpha. Yes or no?
Yes, sir.
Yes.
Now listen to the constraints. Acceleration of this point in this direction should be equal to the acceleration of this point, two ends of the same string.
Yes, sir.
So acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. Acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. We have learned this in relative velocity when we were born.
Yes, sir.
Yes, sir.
Now, acceleration of alpha is like this. Who told you alpha is clockwise? यार आपका equation नहीं तो पता है. You have taken alpha clockwise. mg into L by 2 is I into alpha. mg into L by 2 is giving me clockwise. Yes or no?
Yes, sir.
Yes.
So alpha
Yes.
is clockwise. Who told you that acceleration of center of mass is in the downward direction? Your equation.
Assume.
Didn't decide anything. Somebody could take it upward, somebody can take it anti-clockwise. Whichever directions you take, I'm okay, but stick to that direction till the end of the problem. Now alpha is clockwise. So acceleration of point P with respect to center of mass is L by 2 alpha, R alpha. R alpha is L by 2 alpha, upward direction. Why upwards? Because alpha is in the clockwise direction. Alpha here is clockwise. So R alpha will be upwards. If alpha was anti-clockwise, R alpha would have been downwards. So this will be L by 2 alpha upwards. Acceleration of center of mass. You have taken it downward direction, minus A. Once I make the decision here, life is all about the choices you make. Once you make the decision, stick to that till the end of the problem. The choice you made here was A is in the downward direction. The choice you made here was alpha is in the clockwise. Now till the end of the problem, stick. Think twice before you take a decision. Once you take, stick to it. This will be equal to acceleration of this point with respect to ground. It should be equal to this. Acceleration of the point P with respect to ground will be the same as the acceleration of this point with respect to ground.
Yes, sir.
Right? A is equal to L by 2 alpha. Now, what was asked in the question? Tension was asked. So, how do I do the simplification? mg minus T is m into A. I will substitute from here L by 2. Alpha I will substitute from here 3g by 2l. This will turn out to be L and L will go. Right? This will become 3mg by 4. So tension will become mg by 4. Translational dynamic equation, rotational dynamic equation, constraints. Take it down till here. Same problem. I will take the torque about center of mass and I will show you that you will get the same answer. Why are you doing it? There is a reason why I will be doing it. You will understand that. Take it down.
So
Huh.
can I explain why acceleration of t with respect to ground is zero?
Two ends of the same string. This point are two ends of the same string. I'm equating this acceleration to this acceleration along the length of the string. The length of the string should be constant. Don't you think this and this should have the
Yes,
same
sir.
acceleration? Tangential acceleration. Centripetal end need not be the same. Tangential. And that's why I'm taking R alpha only.
Sir, what was the heading?
No heading for this. Or put it as torque equation. Torque equation. Torque equation. We'll be learning how to take the torque equation in this subtopic.
So,
Huh.
so how did you get acceleration of p with respect to center of mass as L by 2 into alpha?
R alpha. R is L by 2.
Oh, okay, so fine. So for this case, you have assumed point P to be rotating about center of mass, right?
About any point you can take.
Okay.
I can do the reverse. Any point I can take. If I know the acceleration of Q, I can take acceleration of point P with respect to Q plus acceleration of Q with respect to ground. I'll get the acceleration of point P with respect to ground. About Q be कर सकता हूँ, provided I know the acceleration of Q with respect to ground. I don't know. I know only acceleration of center of mass, right? So I took about the center of mass.
Yes, understood.
Right? Now, listen all of you 1 second. Are you able to see this part of the board?
Yes, sir.
Somebody will say, why will I calculate acceleration of point P? I want to calculate acceleration of center of mass. You're welcome. Have a look. Acceleration of center of mass with respect to the point P plus acceleration of point P with respect to ground is acceleration of center of mass with respect to ground. Do you agree with this?
Yes.
Acceleration of C with respect to the point P plus acceleration of point P with respect to ground is acceleration of C with respect to ground. वो भी कर सकते हैं reverse.
सर सेम ही आ जाएगा इससे भी.
हाँ, acceleration of center of mass with respect to point P will be L by 2 alpha in the downward direction. L by 2 alpha. Acceleration of point P with respect to ground is same as that of this. This should be 0. Acceleration of center of mass with respect to ground is A. You can take any way. Somebody will tell me I take acceleration of point P with respect to Q, then acceleration of Q with respect to ground. You're welcome. But make sure that you know the acceleration of Q. If you don't know the acceleration of Q, the purpose is not served, though the equation is valid. Right?
Yes, sir.
So,
So
Hmm.
over here, after finding alpha, if we find the torque about center of mass and then substitute alpha, then we'll get the same answer.
I will do that is what I told you. First, give me the book.
सर ऐसे फील हो रहा है जैसे हम लोग वापस बॉर्न होने वाले हैं इस चैप्टर में.
वापस?
बॉर्न होने वाले हैं सर.
This will take time, but you will, once you get a feel of it, this becomes easy. This is not very difficult. This constraint you will take some time to learn. एक दो lecture लगेंगे.
Answer.
Now, same question, same problem. Procedure 2. Translational dynamic equation mg minus t is m into a. So far, so good. Anybody with a doubt in it?
No, sir.
Talk about center of mass. I'm not taking the talk about point P. Halliday Resnick says you can take the talk about any point. My wish. I'm taking it about center of mass. Right? T into L by 2. Mg will not produce any torque now, only P will produce. T into L by 2 is I into alpha. Do you all agree with that?
Yes.
Are you getting clockwise or anti-clockwise?
Clockwise.
You are able to see that, right? So alpha is in the same
Sir,
direction.
mg on q will also produce torque, right?
Yeah.
mg on q will also produce torque.
mg on q.
मतलब
एक बॉडी का डिफरेंट mgs होंगी.
अरे नहीं
एक बॉडी का
sorry.
एक ही वेट होता है यार.
हाँ
My
हाँ हाँ.
hand weight is 1 kg, this hand weight is 3 kg, belly weight is 40 kgs. ऐसा थोड़ी होता है. When I stand on the weighing machine, पूरा weight दिखाई देगा. Yes or no?
Yes sir. Got
बहुत
it.
बढ़ रहे हो
Sorry.
आजकल.
हाथ का पाँच
ml square by 12 into alpha. Moment of inertia about an axis passing through the center of the rod is
ml square by 12.
now 1 L will go, this will become 6. Alpha is 6 T by ml. My second equation. We should calculate the tension, right? And have three variables. A is one variable, alpha is one variable, T is one variable. Before you start simplification, count the number of variables. Number of equations उतने होनी चाहिए तभी calculate कर पाओ. Right? Acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point P with respect to ground. Acceleration of point P with respect to center of mass L by 2 alpha minus A is 0. L by 2 alpha is equal to A. Right? Alpha is 2A by L or anything. Something that we already did in the previous case, so I am not emphasizing on it. So far, so good. Yes or no?
Yes sir.
Yes, sir.
Now, mg minus t is m into A. I will substitute from there L by 2. Alpha I will substitute from here 6 T by ml. ml will go, 3 will go. I will be left with mg is equal to 4t. T is mg by 4. Same answer.
Yes, sir.
So we are lured to believe that we can take the torque about any point. It's a trap. This problem, torque about both, you will get the same answer. I'll make a small change in this problem and you will see the difference. First, take this down.
Sir,
Ah.
in the third equation, it should be acceleration of c with respect to point P plus acceleration of point P with respect to ground.
What? Mike? You
Sir,
want to
talk
write
about
it
C is
down? Because I took torque about C, I should take constraint of only C is a myth. Previous example, I took torque about point P. But at this end, I showed you how to write acceleration of
yes,
C.
sir. Yes,
You
sir.
got the same thing?
Yes, sir.
Which point I have taken? Alpha is the same for the body. Any point to take, I have no problem with this. Get your keen on it. Acceleration of C with respect to point P plus acceleration of point P with respect to ground is acceleration of C with respect to ground. C with respect to point P, L by 2 alpha downwards. Acceleration of point P is 0. Should be equal to A.
Yes, sir.
Yes.
Done, sir.
So
Hmm.
over after finding alpha, then if we talk about point P and again find alpha and equate both of them, will it always work or only in this case?
Always work. Provided we do the torque right. Taking the torque equation is the key catch. What have I done?
Inclined you.
Inclined at an angle theta.
Question remains the
Same.
Same.
no, it's a D. I will take the torque about one of the point P or center of mass. You will take the torque about the other. Please select my torque. I will be first solving. Torque about point P or torque about center of mass.
Center of mass.
Center of mass.
You want me to solve about center of mass?
Yes.
Yeah. Yes.
First translational dynamic equation mg minus p is m into a. A will be the acceleration of
Center of
Center of mass.
which direction?
downward.
Downwards.
Because mg and t are in vertical directions. So center of mass has no horizontal acceleration. Now you told me to take the torque about center of mass. P into this is theta.
Yes, sir. L by
L
2
by 2 cos theta is equal to I into alpha. Are you convinced by this equation?
Yes,
Yes.
sir.
Yes, sir.
Perpendicular distance from center of mass is L by 2 cos theta. T into L by 2 cos theta is L square by 12 into alpha.
Yes, sir.
One L will get cancelled. Alpha is 6t by ml cos theta. If my calculation is correct, 6t by ml numerator में cos theta. Second equation. Third equation is slightly tricky. Concentrate on this. All of you. Don't even blink. Acceleration of point P with respect to center of mass plus acceleration of center of mass with respect to ground should be equal to acceleration of point P with respect to ground. Problem
Yes.
is acceleration of point P with respect to center of mass is L by 2 alpha this way. Previously, it was very easy for me to add. Both the vectors were in the same direction. Here, both the vectors are not in.
Same direction.
Direction.
So, triangle law or parallelogram law will come into picture. Because
Yes.
A is downwards here. I'll just translate this vector. This A and L by 2 alpha ka resultant when you take. It should either be triangle law or parallelogram law.
Yes, sir.
Yes, sir.
Let us see one step ahead. That resultant you will have to resolve in which direction along the length of the string and equate it to 0.
Yes, sir.
Yes, sir.
Acceleration of point P with respect to ground after you calculate, you will resolve it along the length of the string and equate it to 0. Yes or no?
Yes, sir.
Yes, sir.
So instead of taking the resultant and resolving, resolve and take the resultant.
Yes.
Yes, sir.
If this is theta, this is theta. This will be L by 2 alpha cos theta. L by 2 alpha cos theta minus 0 should be equal to 0. L by 2 alpha cos theta is upwards, A is downwards. L by 2 alpha cos theta minus A should be equal to 0.
Yes, sir.
So A is equal to L by 2 alpha cos theta is my third equation. Right? This when I substitute here, mg minus t is m into L by 2 alpha cos theta. Alpha I will substitute there, mg minus t is m into L by 2 cos theta. Into alpha I take from here 6t by ml cos theta. Alpha is 6t by ml cos theta. 2t cos square theta mg minus t. mg by 1 plus 2 cos square theta is t. Is my calculation correct?
So
Yes,
what
sir.
should 3 cos square theta?
3t cos square.
Yeah.
सर 2 डिवाइड होगा तो 3t होगा
So
मैंने
it's
2 ही
6
लिखा
not 4, right?
So far, so good, right?
Yes.
Now, take it down till here and then take the talk about point P, solve and get the same answer. I am waiting for you.
So for the constraints relationship, you took acceleration along the vertical because that's the resultant, right? Like you want to equate the resultant to 0, right?
Resultant जो भी आएगा उसको along the length of the string equate करने से ही मैं 0 ले सकता
हाँ sir, along that point will be 0.
right? So instead of taking the resultant and resolving it along the length of the string, I resolved the two vectors along the length of the string and took the result.
Okay, sir.
That I equated it to this. So more orthodoxly, I should write this equation as acceleration of point P with respect to center of mass along y-axis plus acceleration of center of mass with respect to ground along y-axis. I'll get the acceleration of point P with respect to the ground along
Y-axis.
So more orthodoxly, the constraint should be written this way. That is what I have taken.
सर आंसर सेम नहीं आ रहा है सर mg cos square theta by 4 आ रहा है
You will not get the same answer. That's why I made you solve. There should be a rectification to be done. First, did you take this down?
So can we solve that one? Can we try it once at least?
Yeah. Please wait.
sir I am getting mg cos square theta by 4
You will get a different answer. Wait for a minute. I need the board to explain why you are getting a different answer. First, take this down. Give me the board. Then I can explain.
Done, sir. सेम नहीं आ रहा
Now listen carefully. Previous example, you took torque about center of mass, you took torque about point P, you got the same answer. So by default, I assumed here also I will get the same answer. If I am not getting the same answer here, first question why? Second, then in the previous example, why did you get the answer? Fair enough?
Yes, sir.
Now, listen carefully. In this case, point P has L by 2 alpha acceleration with respect to center of mass along y-axis. Along x-axis, it has got L by 2 alpha sine theta. Do you agree with that?
Yes, sir.
Yes, sir.
So are you trying to tell me acceleration of point P with respect to center of mass along x-axis plus acceleration of center of mass with respect to the ground along x-axis will be acceleration of point P with respect to the ground along x-axis?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Acceleration of point P with respect to center of mass is L by 2 alpha sine theta. Center of mass with respect to ground has only vertical acceleration, right?
Yes, sir.
So acceleration of point P with respect to the ground along x-axis is not zero. ये क्या बोल रहे हो यार? अभी whether it is zero or not क्या लेना देना है? अरे भाई साहब, अगर टॉर्क के अबाउट पॉइंट P ले रहे हो, पॉइंट P is an accelerating frame of reference. जब हम पैदा हुए, we have learned that if you are about the accelerating point, you will have to introduce a
Pseudo force.
Force.
Opposite to the direction of acceleration of this particular point.
Yes, sir.
So when you people took the torque equation about point P, you have taken mg into L by 2 cos theta. Till here you are right. Mg into L by 2 cos theta. But you took only this. You forgot the pseudo force. M into L by 2 alpha sin theta. This is called pseudo force. Where will you introduce pseudo force? Always on the center of mass. Which direction? Opposite to the direction of acceleration of the frame. So if this has an acceleration this way, this will have acceleration to the right. So am I supposed to take the torque due to pseudo force as well? Yes. Now listen. When I am taking torque due to this, it's clockwise. Pseudo force also is clockwise. Extend the line of action of pseudo force and drop a perpendicular m L by 2 alpha sin theta, mass into acceleration, into this perpendicular distance. This will be L by 2 sin theta.
Yes, sir.
Agreed? Mass into acceleration, extend the line of action of the force and drop a perpendicular from the point P. This will be L by 2 sin theta. So torque will be ml square by 3 into alpha, I alpha. Torque about point P, moment of inertia will be about point P. This will be mgl by 2 cos theta plus m L square by 4 alpha sin square theta. This is my second equation where you people have gone wrong. First, second and third equation अभी अगर simplify करोगे answer आए. Get your answer, then I will answer the remaining doubts that you will get. First, take this down, write this as pseudo force, and convince yourself that you are getting the same answer from these three equations. Then I will answer the remaining doubts that you will get.
So,
Hmm.
so if that point P had an acceleration all throughout, in that horizontal direction, so then why didn't we put that in the torque equation when we were solving it about C?
About C solve कर रहे हो तो P का कैसा लगाओगे? कहाँ पर लगाना है इस इक्वेशन? I didn't get your doubt. I want you to put it this way. Which equation do you want me to change and by what line?
Oh, sir, I understood now. I understood why. I got it. Yeah.
I'll put the question in a different way. This doubt quite a few students will get after some time. Point P is accelerating, hence you took a pseudo force, right?
Yes, sir.
So when you take the torque about point C is also accelerating.
Yes, sir.
तो टॉर्क ड्यू टू pseudo force क्यों नहीं लिया तब आपने?
दोनों साइड में कैंसिल हो जाए.
Talk about center 0.
pseudo force है टॉर्क अबाउट C जब ले रहे हो, even if it is accelerating, you put a pseudo force, torque due to that force will become
Zero.
zero because it is passing through the center of mass.
Yes.
Right? Hence, taking the torque about center of mass anytime is the safest bet. But mind my language, I said it is the safest bet. तो ये सब क्यों पढ़ा रहे हो यार? बस एक रूल डिक्टेट कर लो. Always take the torque about center of mass. बात खत्म. We will not go wrong. There will be situations where you are forced to move away from the center of mass. Then you should know which all points you have to select. First complete this and dictate those points. Tell me if you are getting the same answer or not.
Yes, sir. Same answer.
So,
Hmm.
so when we take pseudo force due to C, it will act on P, right, in upward direction. So
I'll hang
that
you
should come.
upside down. I'll hang you upside down. Such a confusing statement I never get to see. You will put pseudo force on P when you are taking the torque about center of mass. Pseudo force कभी भी center of mass पर ही लगे, कहीं और नहीं लगाना. अब
Okay,
यहाँ
sir.
पर खड़े हो तो उस पर डाल दोगे.
Okay, so got it.
Vector sum of all the forces is mass into acceleration. Why do we take acceleration is acceleration of center of mass? Because all forces appear to act from
Center of mass.
one center of mass.
Yes, sir. Got it.
Write down 3 notes. Are you people done with the simplification?
Yes.
Note. N-O-T-E. Note. First point. Preferably take the torque about center of mass of the body. First point. Preferably take the torque about center of mass of the body. Preferably take the torque about center of mass of the body. हो गया?
Yes, sir.
Yes, sir.
Second point, if not the center of mass, select a point which is not accelerating. If not the center of mass, select a point which is not accelerating. If not the center of mass, select a point which is not accelerating. Third point, if the point is accelerating, do take the torque due to pseudo force as well. Do take the torque due to pseudo force as well. Do take the torque due to pseudo force as well. Now listen to the second point. What did you tell me in the second point? If not the center of mass, select a point which is not accelerating. That is what I did in the start. When you had a thin rod in the horizontal position, this way, I was damn sure that point P's acceleration is 0 because it doesn't have L by 2 alpha this way. It has got L by 2 alpha this way. This is a L by 2 alpha with respect to center of mass. I got point P's acceleration only in the vertical direction, which I equated it to 0. It was fair enough. So here, why did you get the answer when you took the torque about two different points? I will get the answer whether you take the torque about center of mass or about a point which is not
Accelerating.
Chance the point P is accelerating. Here vertical acceleration is 0 but not horizontal. If it is accelerating, take the torque due to pseudo force as well. You will get the answer. Is the complete logic clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now, none of the textbooks will explain this in detail to you. They'll say take the torque about any point. Right? But then, if you are taking a accelerating point, you will have to introduce the pseudo force. This is not clearly specified by Halliday-Resnick. But now you see after solving this problem that you will have to take the torque due to pseudo force. इतना माथा पेची क्यों करो यार एग्जाम में मुझे? I'll directly take the torque about center of mass always. Always you cannot take the torque about center of mass. You will be forced to shift from the center of mass in some point. Can you show me an example where I will be forced to shift away from the center of mass? Suppose you deal with a hinge, which will be the next subtopic that we deal with. What is a hinge? Hinge is a thin rod inside a groove. I press it to the right, normal force is to the left. I press it to the left, normal force is to the right. So when I take a hinge force, it will have an Nx and Ny component. I will have two forces here. It will have an Nx and Ny. Quite obvious. I hinge a rod and I leave it, it's falling this way. Center of mass is going in the forward direction.
Yes, sir.
Center of mass is accelerating in the forward direction. What is the horizontal force? Next, center of mass is accelerating downwards but not with G. So there is some force in the vertical direction, Ny. Depending on these two values, the direction of normal force will be decided. So this is a complex thing. Now equation में मुझे ना Nx चाहिए ना Ny चाहिए. हेडेक है, दो वेरिएबल, एलिमिनेट देम। ऐसा कैसे एलिमिनेट कर लोगे यार? टेक द टॉर्क अबाउट द हिंज, इट इज mg into l by 2, एक स्टेप में आंसर आ जाएगा, mg into l by 2 cos theta is equal to I alpha. अल्फा आ गया कि नहीं?
Yes, sir.
Yes, sir.
Here I am forced to shift away from the center of mass. I am taking the torque about the hinge. So there will be million instances where you will be forced to shift away. If you would have taken about the center of mass, two variables called nx and ny are walking into your life.
Yes, sir.
So alpha is one variable, nx is one variable, ny is one variable. तीन equation simplify करना पड़ेगा. Instead, take the torque about the hinge. Job done. Alpha एक step में आ जाए. It depends on the question asked. If he asks for alpha, in one step you will get the answer. So shifting away from the center of mass quite a few times is our requirement. But make sure that the point is not
Accelerating.
now hinge to every time is fixed. No, yaar, need not be. Tomorrow this hinge will be placed on a truck this way. A truck is accelerating. A hinge is not an accelerate, is not a non-accelerating point. Hinge भी truck के साथ accelerate कर रहा है. Yes or no?
Yes, sir.
Yes, sir.
If I take the torque about the hinge, I'll have to introduce a pseudo force of MA. I'll have to take the torque due to mg and MA. Only then I will get the correct answer. Is the complete concept clear?
Yes, sir.
Blindly, first instance, don't go for the center of mass. See your convenience. मुझे एग्जाम में ये सब नहीं दिख रहा यार. I'm in a hurry. I'm under tension. I'm under pressure. Take the torque about center of mass. 100% you'll get the answer without fail. Center of mass will never fail you. No restrictions for that. But if I want to shift away from the center of mass, please first make sure if you're eligible to take the torque about that point. It is a non-accelerating point. I am more than happy to take the torque. If it is accelerating, you should know the acceleration of that point. That is the key catch. I know the acceleration of this hinge is same as that of the truck because the hinge is fixed to the truck. So I put a pseudo force. If I didn't know the acceleration of the truck, my hands are tied. I will not know the pseudo force. So I will be forced to take the torque about center of mass only. First important concept in rotational dynamics. How to take the torque equation. आई बात समझ में?
Yes, sir.
One second. Okay. Now just for practice. I'll put it this way. This is a table. With a peg on the top. There is a thin rod released from here. There is a thin rod released from here. This distance is x. I have normal force here, mg here. M is the mass of the rod, L is the length of the rod. Obviously, the rod will start rotating. Yes or no?
Yes, sir. Yes, sir.
Find the value of x Find the value of x for which alpha is maximum when released. Find the value of x for which alpha is maximum when released. You try the problem.
Yes, sir.
Yes, sir.
No big deal. Translational dynamic equation, rotational dynamic equation, exactly on the same lines.
So is it L square by 6G?
No.
So is it 5/3?
9.
Further solve.
First
1 minute.
equation is
So to find the moment of inertia about that pivot, we have to use parallel axis theorem, right?
naturally.
So can you just tell me if that main equation is right? Because फिर पता चलेगा if I've just made a calculation error. So the torque is equal to mg into x.
Your classmates are asking me to wait so that they want to attend.
Oh, so I didn't hear that. So sorry.
And you want to announce the equations.
So sorry.
Listen, translational dynamic equation mg minus n is equal to m into a.
Yes, sir.
A will be the acceleration of what?
Center of
Center of
Center of
mass.
Center of mass. Acceleration of c. Now torque equation here I am eligible to take about 2 points. Center of mass will be same. Center of mass अगर लोगे तो unnecessarily you will introduce n no यार. n already I have in my equation. Either way that's a headache for me.
Yes, sir.
Right? If I didn't have n in my equations, then 100% I would have taken torque about O. Right? But now because of the translational dynamic equation, n has already walked into my life. Now what do? Take the torque about C. It will be n into x is ml square by 12 into alpha. Now people who took the torque about O, you will get mg into x is I into alpha. Nothing wrong. Comfortably you can go ahead with that. Point at O is not accelerating. So it's a non-accelerating point. You can take the torque even about O. Torque about O is mg into x is ml square by 12 into alpha. Sorry, about O will be ml I into alpha. This will be ml square by 12 plus m into x square, that into alpha. Somebody who has taken the torque about O, you will get this equation. Torque about center of mass, you will get this equation. Be selective in doing this. Why did I prefer center of mass? Unnecessarily you are introducing a variable n. N is already there in my first equation. So I at least will be simplified. Now here I will be ml square by 12 plus mx square. Right? So now this is my second equation. How many variables do you have? N is one variable, x is one variable. Sorry, x is what you'll have to calculate. AC is one variable, alpha is one variable. Now, constraint relations. Acceleration of O with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of O with respect to ground. Acceleration of O with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of O with respect to ground. Acceleration of O with respect to center of mass is x into alpha upwards. Acceleration of center of mass is a downwards. Acceleration of O with respect to the ground is 0. I get A is equal to x into alpha is my third equation. Now what is your requirement? I want alpha in terms of x. Why do you need alpha in terms of x? वही तो पूछा है आपने. Tell me the alpha maximum value of alpha. Find the value of x for which alpha is maximum.
So we'll eliminate A.
So eliminate n. This is acceleration of center of mass. Right? AC I will substitute here. mg minus n is m into x alpha. AC I took from here. Now n how do I get? mg minus ml square by 12 n. Sorry, x. N is ml square alpha by 12. I got x to the denominator. Is equal to m alpha into x. M gets cancelled. G is equal to, take alpha common, L square by 12x plus x. Is my calculation correct?
Yes, sir.
Now differentiate this equation d alpha, or put it as alpha is G divided by L square by 12x plus x. Now you have to do d alpha by dx equated to 0.
So, does the answer come out to be x is equal to L by 2 root 3?
No. 2 root 3 G by L. Root 3 G by L. Differentiate this. Don't get worried by seeing u by v. Denominator square. When you equate it to 0, it will go. Simplification is quite easy. Don't get frightened. I'm waiting for you people. Suppose you are unable to do the simplification, I'll rub the board and I'll do it. It will take me 1 or 2 steps of the space on the board. Point 2 is on the peg. Till the rod rotates and starts sliding, point 2 will be at rest, not accelerating. It is kept on the peg. It is kept this way. So after some time, it will start slipping once it rotates. Initially in the horizontal position, point 2 will not accelerate because it is on the peg.
So same even I'm getting L by 2 root 3 only.
Yes.
The G gets cancelled out.
L by 2 root 3. It seems X is L by 2 root 3 in the numerator or denominator?
Denominator.
Yes, sir.
Makes sense because, sorry, I told you the value of alpha. Sorry, I have been telling you the value of alpha. My mistake.
So G to will go now when you are differentiating. And
Dimensionally also X में G नहीं होगा. I have been telling you the value of alpha. Now what is the minimum alpha? Put this value of X here, you get it in terms of G. Put this X value here and here, you get it in terms of G. I have been telling you the minimum alpha. My mistake.
so for this question, won't that right wala formula be easier, like shorter to solve?
This plus mx square no yaar. Either way, when I differentiate, this becomes 0 is the differentiation. I would generally prefer center of mass. Only if I am forced to shift from the center of mass. You tell me first dynamic equation की जरूरत ही नहीं. So now I want to avoid normal force. Then I take the torque about the peg. Either way, now you people are confident, right? You know either about the center of mass or about a non-accelerating point. If the point is accelerating, torque due to pseudo force must not be forgotten.
Yes.
Same problem, slightly twisted. This is a thin rod of length 1 meter. This is 0.6 meters. This is 0.4 meters. Tied by a string here, connected by a spring. And K is 10 Newton per meter. Elongation is 0.1 meter. See, on this peg, if the string was not tight, the rod would have gone this way. Yes or no?
Yes, sir.
You made it straight and you tied it to this end. Right? Mass of the rod is 1 kg. Mass of the rod is 1 kg. Length of the rod is 1 meter. In the horizontal position, elongation of the spring is 0.1 meter. Right? Find the normal force N if this string is cut. Find N at this instance. The moment you cut the string, find the normal force at this instance.
0.1 meter elongation, right?
Yeah. When the rod is horizontal. When the rod is horizontal, 0.1 meter is the elongation.
Sir, I have sent you a constraint, sir. Can you please check it? The constraint of this.
No, you sent it to the co-host by mistake. Co-host का email self. Minus a is equal to 0, right?
Okay, sir.
So,
Hmm.
so I have a very silly question.
Hello.
So why do we take the acceleration of that pivot to be 0? Like the point at the pivot.
It's fixed in mind. The pivot is fixed, and the rod above that till it slide doesn't have an acceleration. The rod will turn this way, and once it starts sliding, it will have a linear acceleration. Till then, that point wahi par.
Okay, so understood now.
Now listen. First,
One minute.
translational dynamic equation. It is mg minus n plus kx is equal to I. First equation, is it clear to all? All
Yes,
the
sir.
people who have forgotten kx have committed a blunder. Mg plus kx minus n is m into a. A is the acceleration of
Center of mass.
center of mass of the body. Translational dynamic equation. Rotational dynamic equation. Should we take the talk about center of mass or about the type?
Center of
Talk about center of mass is n into 0.1. This distance is 0.1 and it's clockwise. I'm taking clockwise torque as positive. Now, kx into 0.5, that's also clockwise. Kx into 0.5 ml square by 12 into alpha. Agreed? Translational dynamic equation, rotational dynamic equation. Constraint relations. You will call this the peg P, this is the center of mass C. Acceleration of the point peg with respect to center of mass plus acceleration of center of mass with respect to the ground is acceleration of the peg with respect to ground. Peg with respect to ground, right? This is 0.1 alpha in the upward direction minus AC in the downward direction should be 0. 3 equations and 3 variables. You see how frequently this system is following us. Translational dynamic equation, rotational dynamic equation, and constraint relations. All you need to calculate here is n. Don't eliminate n. Generally, we eliminate n. Here you need to calculate n. So eliminate alpha and AC. Alpha and AC. Right? Eliminate alpha and AC. You have 3 equations and 3 variables. Kx, x is not a variable. Remember that this is 10, this is 0.1. This is 10, this is 0.1. Mass of the rod is given as 1.
Yes, sir, done.
Next, we need to introduce this kinetic energy of a rigid body. Till now, you know kinetic energy of only a point mass. It was half mv square. Now we
Yes, sir,
will
in
be
COM.
So can you show the torque equation if you take about point P?
talk about point P. will be mg into 0.1 plus kx into 0.6 is ml square by 12 plus m into 0.1 whole square into 1.
So the last step is parallel axis theorem, right?
Obviously,
Okay.
टॉर्क जिस पॉइंट पर ले रहे हो मोमेंट ऑफ इनर्शिया उसी पॉइंट के एक्सिस पर डिफाइन हो.
Yes.
ये पर इससे ज्यादा डिफिकल्ट होगा अभी कि
This level will maintain for some time.
So what is the answer?
I don't know.
65/7 U.
इतना गंदा नंबर दिया, 10 दिया, 0.1 दिया, मास 1 दिया.
divide
Sir,
होगा.
Excel में.
I thought I gave good numbers. I don't know.
आज का क्लास पूरा रिवाइज करना पड़ेगा प्रॉपर.
Every class from here will be this important for the next 6-7 lectures. So by chance, if ours is the first lecture, please join the class in time. Early in the morning, get up and wash your face with cold water. At least if you don't have a shower, then you will be fresh in the class. Is that clear?
Yes.
When is the next lecture?
So next lecture, sir, I don't know. I'm not seeing.
Friday.
Yes,
Friday,
this week,
Saturday.
no lecture.
Saturday.
संडे को डाउट लेक्चर है.
हाँ सर संडे.
Sir,
I think there is a mistake in the timetable. Sunday's doubt lecture is not mine. मुझे एक और lecture लगा हुआ है. So Sunday's doubt lecture नहीं होगा. वो lecture इस बीच में ही लेना पड़ेगा.
फिर 11 to 1 है हमारा संडे को.
हाँ, मेरा timetable में कुछ और है. Friday 5 और people will wake up and they'll tell us sir थोड़ा change है ये करवा दीजिए. Last week भी एक ऐसा lecture हुआ था. I had with you people Friday 3rd lecture. वो timetable में was clashing with some.
4-5 के साथ गिवन आपका संडे लेक्चर.
हाँ, तो थोड़ा गड़बड़ हुआ है. इस बार भी Sunday 11 o'clock is not my lecture. So we will then Saturday remind me Saturday शाम को वो Sunday का डाउट लेक्चर ले लूं. एक डाउट लेक्चर लेना जरूरी है क्योंकि इसका सेंटर ऑफ मास कंजर्वेशन ऑफ मोमेंटम का खत्म नहीं हुआ. Right?
Yes, sir.
See you people in the next class.
So now you're only the permanent teacher for Zenith 456.
Yeah, I think
इससे पहले who was teaching them?
somebody from Delhi was teaching. He was COVID positive, so they changed the timetable. Now from March 1st, whole of the timetable will reshuffle.
No, अच्छा.